and you had a good night, and that you have heard a lot of scenario technique from Adriana. And now I first want to comment shortly about the results which have been uploaded to the own cloud server. And thanks for everybody who joined us yesterday and worked with us. And Lena Kronemeyer and I, we have picked one of the results, and we'd like to share that with you. So just a moment, we can open the screen and take this one. No, sorry. I'm lost in Zoom space. So I have to check the correct PowerPoint. And it's this one. Now I can share the screen. And it was hands-on scenario planning. And you can see my screen? Yes. Okay. And it was from group number 2, I guess. And they made a selection. So the task was to look at the morphological table, which we sent to you, and to select 2 of the descriptors, how we call the key factors, and to make dominant dramas like that. And group 2, they selected as first dominant descriptor the employment relationship. And so we are here. And they argued that employment relationship is important because digitalization has called for flexibility in labor laws, and this is a trend for the coming years. Yes, I see that similarly. So flexibility is the question, how will it be developed in the future? And they used as a second dominant descriptor the working environment. Where will we work in the future? And so we have selected 2 out of the 10 dominant descriptors. And then they filled out the matrix, the small matrix. So we have here the descriptor number 1, and the 2 projections is we do traditional working. So we work as we do it today in the future as well. Or the opposite is completely virtual. Nobody works in a workspace. Everybody works in a virtual reality, in a virtual environment. And here you can see that these projections are really opposite. So there's no mix of them. It's really opposite to show there are 2 possible futures which are represented by these 2 different projections. And then the second descriptor is in the columns, and we have here self-employment compared with warranted. We have 2 different projections here as well. And when we combine these projections with each other, we come to these fields 1 and 2. And now the group has developed 2 stories. And the first story is Jetson's scenario, completely virtual plus self-employment. And they first listed the projections in this scenario in the year 2100. Professional activities will be carried out using technologies and holograms, resulting in a totally virtual service. This allows professionals to work for several companies at the same time and in different thematic and cultural environments. So we have multitasking of the workforce. And then there is a narrative. Anna needs to wake up at 4 a.m. This is really, really early, isn't it? Even though she lives in Brazil, her clients are from Asia. After the first meeting, she makes a self-care routine from a virtual reality in which she will be accompanied by friends and family. Then she continues her independent service with clients from Africa, which requires other social behaviors. That's interesting, due to cultural and language differences. Anna uses an application that translates simultaneously in all her meetings to be able to communicate in different dialects and better serve her contractors. So this is a nice short story. It's only a short story, but you have had only to select 2 of the projections. And here you can see how these scenarios are normally developed. You start with the projections, but then you think, okay, what does it mean? What does it mean for a person when she wakes up? And here she has to wake up very early because she serves customers in Asia. And how is family organized in such a world? And then you write a story and you invite other people to come into this virtual world, into this scenario, and to not only get the facts, but also get kind of a feeling, kind of emotions, which are accompanied by this scenario. Very good, but not enough, because scenario technique necessarily says we have to write 2 scenarios at least. And so we just go on and see there's a second scenario, and there is the Flintstones scenario warranted in traditional working. And this is the opposite scenario to the first scenario, which shows there is still a probability for another world. And when we think about consequences out of these scenarios, we have to find normally steps or measures which are robust, which are well fitting to both of the different scenarios. And now let's have a look what's going on here. Zhao wakes up at 6 a.m. to go to his face-to-face work, in which he is located in the same environment in which he lives. He goes to the company cafeteria where he eats all his meals and can save money due to the lack of resources the world faces. It's not a nice world. Technology is present in your routine, but to get this job, it was necessary to specialize in software that dominates all the activities of your day. Zhao was lucky to have a steady job in a scenario of high unemployment and no job stability. So this is a different world. And as I said yesterday, it's always dangerous to say the first one is the good world and the second one is the bad world. I wouldn't do that. I would just keep those sentiments out of the scenarios. I would say this is the first one is the green world and the second one is the blue world, and in between will be the truth. And so we have to face both possibilities of those scenarios. Very good. So thank you very much for uploading your results. And we have received one other slide from group number 5. Thank you for that as well. And if the other groups want to upload their slides, even if there are no scenarios written, please do so, because it's sometimes also good to see what different projections and what different descriptors have been selected in order to proceed with this task. Good, thank you very much for that. So this was a little bit feedback to yesterday, and I invite you to give us some of your experiences or of your emotions as well when you did the task yesterday, or when you did scenarios in your professional practice. So please feel invited. And I remember one participant who wrote before we started that he has some customers and he has to do some scenarios for them, and he or she has to develop roadmaps for them. Perhaps we can have a short, I think it was Antonio, a short feedback if you are now prepared to start a scenario workshop. Okay, he don't want to talk with us at the moment, so perhaps we will have later on the opportunity to talk with him. Good. Okay, so from our side, we were happy with the exercise yesterday, and now we will start into the last day of the Enrich course, and this last day will be about the building blocks which we use for Foresight. And I'd like to share my screen again, but first I have to stop the first presentation and go into the second presentation. So here it is. Again, share the screen. So we are now in day number 5, data and text mining for Foresight. And that means that we focus today not on the methods of Foresight, but we focus on the building blocks. And I'd like to explain in a minute what I mean with methods and what I mean with building blocks. So let's start on that day, just giving you an overview of the timetable of our schedule. First, I'd like to give you some ideas about data and text mining for Foresight. That will take more or less 1 hour. Then we will have a break, a coffee break, and then we will do exercises as yesterday. But today we will have 3 different exercises, and you are invited to select one of these 3 exercises. Finally, we will have some experiences from the IPME, which is my institute, with those building blocks in combination with methods of future research, and a closing discussion in which I will try to have a look back to the overview, what future research methods there are in the world and how they can be combined and how they can be used and what are their advantages and disadvantages. I think that is good for the closing discussion taking place in the last half hour of our training day. Good. So let's go into data and text mining for Foresight. And first of all, I'd like to just give you again the terms which I use in order to have a common understanding what we are talking about. So in this blue fields, we have the so-called methods. And the methods are the Delphi method or the scenario method. And I understand a method as a stepwise procedure which you can control, which you can document step by step, and which produces some insights about the future. This is my definition of method. Others may define it differently, but just for our understanding that we have a common language, this is a method. Then we have the building blocks here, and these are the blue, dark blue circles. And these building blocks, they support methods. They allow us to get an introduction into a method. They allow us to structure a field and to understand which different aspects we have to consider. And these building blocks, they are today normally based on 2 or 3 sources. First source is here, big data. Today we have so much data available that future research is dealing a lot with the analysis of data, because the data can help us saving a lot of money, which we have to spend for expert knowledge if we don't use data. And normally we have different building blocks in a method or combined with a method. So for instance, if I look at the example from Adriana from yesterday, in which she talked about the biotechnology in Brazil, she said there was a topic which was the intellectual property. So a building block could be to analyze the intellectual property in that field and to get insights about the regional distribution, to get insights about the content-oriented distribution of this intellectual property. and to use this as an input for a scenario method, which is a method. And you could combine it, and in that example, it was combined. You could combine it with expert knowledge, in which different experts were asked for their opinion about this topic. So you need building blocks as input to the methods. And then we have a large line around here, and I call this approaches. And approaches, it's an easy word for things such as foresight or road mapping, in which you normally combine methods and building blocks. So if you have different methods and you have different building blocks combined, then we are talking about an approach. Foresight approaches from many ministries are formed in that way. And if we only have a method and some building blocks, we call it a method. And so we have a common understanding of what we are talking about. Okay, this is the intro. And now we are going to the methods, to the building blocks. And especially we are going to big data analysis. And big data analysis is something which has come up in the last 20 years. In the first years, it was still quite hard to get data. Today, it's normally not a problem to get data. It's normally more the problem to use this data properly and in a good way. And so we have a lot of new opportunities based on this big data concept. And here is a nice slide which I found, and it shows what big data really means. And for instance, two examples. Every minute of the day in the year 2020, the last year, every minute, 319 new users entered the Twitter universe. 319 users per minute. That makes per day multiplied with 60, multiplied with 24. And you can imagine this is a huge amount of users. And what is good for us as Foresight experts, good is that we can use these people, we can use these Twitter accounts, for instance, to search for experts. So if we are doing a study on biotechnology, we can look in Twitter at the hashtag biotechnology, and perhaps we find people from the biotechnology industry, but perhaps we find also people who are against biotechnology, for instance, from non-official agencies or from associations. And we can find a lot of information about those people. And when we make a selection of experts, we can use this information to get an interesting, perhaps contrasting group of experts to discuss this topic. So this is only one example. And another example, I think Facebook is also here. Yes, here's Facebook. 150,000 pictures, photos are uploaded by Facebook users every minute. And again, this is a huge amount of data, and perhaps we don't have the tools at the moment to analyze all this data. But if you think of artificial intelligence and so on, we can also access this visual data for our purposes of future research. So big data offers an immense amount of opportunities. And there are more examples, but I think these two examples are quite impressive. Now that I said something positive about big data, let's have a short look at the 7 challenges of big data. And these 7 challenges are normally abbreviated with the 7 V. And the first 3 V are here on this slide: volume, variety, velocity. That means volume data is big. Yeah, we have a lot of data and we have to analyze it. and we need a lot of capacity with computers to do so. And so this is one of the first challenges. Then data variety. So we have not one specific type of data. We have different data, we have pictures, we have audio parts, we have texts, we have structured texts, and so on. So this is the second challenge. Then data velocity, data is fast. Sometimes we need real-time analysis because it's so fast, for instance, in sentiment analysis, that we have to be very quick to get the right information out of the data. Okay, and these 3 V's are accompanied by other 4 V's, and these are by different companies. So, for instance, veracity, unreliability of information found in big data. Sometimes you find opposite information. Think of fake news. You find news and you find fake news. Then variability, the flow rates are different of different types of platforms. The value is discussed as a challenge in big data. And last but not least, how do we visualize the analysis that we find? How can we give other people a quick impression what big data can give to us? Okay, I don't want to go into more details of big data, just to give you an impression what the opportunities, but also what the challenges are if you are working with that source of information. Now let's look at the building blocks for our Foresight methods. And I'd like to separate between 3 different building blocks. First are data-driven building blocks, and we just talked about that. And traditionally, these are publication analysis, which can be done quite quickly nowadays. These are patent and other intellectual property rights analysis, and which are block analysis, which is quite an interesting source for our findings. And we can add to that Twitter nowadays or web analysis. So this is data-driven. This is the first type of blocks, building blocks that we can rely on when we do Foresight exercises. Second is very traditional. It's expert-driven. And that means expert interviews, reading things in periodicals, for instance, visiting trade fairs and workshops. These can be used to get access to experts, to get their opinion, to get their feeling what the topic is about. And so we have a second type of building block. And the third type of building block is, in my opinion, quite interesting, because it is a building block which is able to increase the acceptance of our methods and our findings. And we have called that participation-driven building blocks. So for instance, if you have made a scenario analysis, then you can discuss this on moderated platforms. To give you an example, which you already know, when the project team Future Work 2100 did the scenario exercise, they said, okay, we have to stop after finding our T factors and projections. And before we go further, we have to discuss this step with experts from the field of labor organization. We have to discuss this with experts on the field of forecasting. And so they made a public conference out of that. And they discussed the descriptors and the projections before they went further on. And they changed something and they improved the list of these things. So this would be a kind of a moderated discussion platform using for creating acceptance. Yeah, because if you do such a thing, then you can always argue afterwards that experts have validated your assumptions, and that this is not only the idea of the project team, it's also the idea of a validation by experts in such a moderated discussion platform. Or you can even invite people, the public, to discuss your findings. And I know that especially from forecasting exercises in cities and regions, when they develop such a scenario, then they present it to the public, and they normally use a web page and present it there, and then they invite all people living in that area to comment on the scenarios or comment on the measures driven by the scenarios, so that one can see if the public accepts those things, or if there are even better ideas, or if there is resistance against those ideas, so that you do not only have the analysis on one side, but you also have the analysis of the acceptance on the other side. So these are participation-driven building blocks, which can be used quite nicely if you are doing a public kind of forecasting. Good. In red color, there are two things: patent and other IP rights and block analysis. And these things we will deepen later on in our exercise today. So we already made that in red color, that you can see what is going on later on. Okay, now that we have seen this overview about the different building blocks, I'd like to give you some building blocks in a nutshell. Not all building blocks. I selected some of those things because we have experience in these specific things, because they are quite important, because you can use them quite easily. And so I selected 4 different things: text mining, topic modeling, sentiment analysis, and qualitative expert interviews, to show that there are different approaches and how they are used today. And if you have used one of those things, please feel free to step into the presentation and to comment on it, and to say if you have liked it or not, and which part of it. And so please feel free to step in the discussion. Let's start. Text mining. Text mining is about language, about grammar, about words. And text mining normally relies on data which is in a written form. So we cannot make text mining if we only have a picture, but we can make text mining if we have a picture with a description, or if we have a written text which we can analyze with the help of the computer. And just let me have a look into the chat. And okay, because I thought perhaps there would be an opinion, but it's just about organization. Okay, so when we do text mining, we need a text. And normally the texts which we use are having different features, different characteristics. And I'd like to show you this with the example of a patent, which you can see here. It's a patent from the US Patent and Trademark Office. And we have 2 different parts which we can use differently. We have the bibliographic information on one side, and we have the textual information on the other side. So what you can see here in the upper left area is the bibliographic information. And for instance, this patent says who is the inventor. It says which company is the assigning company. It says when has it been filed, in which international patent classes has it been assigned, in which patent classes has the research been done, and so on. And you also see the examiners and the attorneys as bibliographic information. So we can use this, for instance, to put it into a database and to make, based on that, specific analysis. For instance, we could say in the biotechnological example from yesterday, we want to see the development of biotechnological patents in the course of time. And so we make an analysis how many patents have been applied for in the year 1919, 1991, and so on. And we can see if there is a development, if there is a growth, or if there is already a decrease. And we can get some first information, descriptive information in the field. This is what we can do with bibliographic information. Then we have in the same document text. Text is not so easy to use because it normally is unstructured. You don't have a specific structure, and neither in patents nor in publications there is a specific structure requested. You can do it in the way more or less in which you want, or in which here, in that case, the patent attorney is used to do it. So it's quite unstructured, but we still want to get some information out of that. And how can we do that? We can, here we are. We can, okay, before I come to the extraction, let me just show you the second type of source. First type of source, patents or publications. Second type of source here are blogs, blog information. And it's similar to the first type. We have types of structured information. For instance, we have here a blog from the DLR, which is the hosting organization of Enrich here at the moment. And they write interesting things on their blogs. We will see that later on in the exercise. And we have structured information as well. For instance, the publication date or the topic of the author. And we have unstructured information, textual information, and we want to do something with it. We will want to use it for our building block analysis. For instance, this is, I think, a rover for the Mars. And when we are doing an exercise for the Mars, that could be an input. Now, what is text mining doing in addition to the bibliographical information? We have here a short workflow diagram, and you see here, we have here text input. It's just simple text, and the text input has to be in a specific format. Normally, it's first transferred, and then we put it into a text database. And out of this database, we can do statistic analysis and we can do linguistic analysis with these texts. For instance, we can search for similarities between the texts, or we can search for clusters in the text. So we have here clustering, classification. You have 3,000 documents, you have 3,000 publications around biotechnology, and now you don't want to read all of them, but you want to have some clusters, what they are talking about, and so you're doing text mining and measuring similarities, and based on that, a cluster analysis to get a classification of those texts. Or you can do indexing and extraction of important terms. What are the upcoming terms? What are the terms that decrease in their importance, so that you get some access to the contents of your documents without reading them document by document. And I think that's the great idea behind text mining, that you can proceed with a huge amount of data. So for some of our analysis, we use patent data And if we have a technological field such as the RFID technology with 70,000 patents, that's no problem because the computer does the job. The computer helps us to get access without having to read everything. And finally, you can do visualization. So you can show these clusters, for instance, and how they are located next to each other. And you can present what in those texts really is. So this is quite helpful, especially if you have large amount of text and you want to extract information out of it. Now, in our institute, we have developed a tool which is called Padvisor. Unfortunately, it's in German language, but fortunately, you can download it for free. It's an open tool. And if you are interested in, just send us a mail and we look if we can help you with that tool. It is specifically for analyzing patterns, specifically for analyzing US patterns. So if you are interested in that type of stuff, just send us a mail and we try to help you with that. And one of the things I'd like to show you what we are doing when we make text analysis, we try to analyze so-called n-grams. And here we have an example for it. Now imagine a text and we have here a sentence which is one example. The nanotechnology plays a central role for growth. Now we want to find similarities between this text and other texts, and we extract for that purpose so-called n-grams. An n-gram is called a unigram if you have only one word. It's called a b-gram if you have two words, a trigram with 3 words, and so on. It's quite simple. And what we are doing, what we have developed here is to use a so-called window to move it over the text. And I'd like to show it here in this example. First, we kill some words. We kill so-called stop words, words without meaning. They are filtered out by stop word filters. And so here in this example, the is an article which is not needed, is an article for, there is a preposition which is not needed. So what remains is nanotechnology plays central role growth. And now we use the window of 3 in that example to extract b-grams. That means combinations of 2 terms. And if we have the window of 3 about the first 3 terms, then we can extract 3 different b-grams, namely nanotechnology play, nanotechnology central, and play central. And the idea behind this is that not only words which are directly next to each other have a meaning with each other, but also that words who are not far away from each other, in that case 3 words away, they have something to do with each other. So it makes sense not only to extract nanotechnology play and play central, but also to extract nanotechnology central. So this is just an example what text extraction starts with. And then you can imagine that you have your text, and then you have a list of your n-grams, and then you can combine them with the n-grams of another text and find similarities. You can find important words in that text and can do a lot of funny research with that. In the end, these analyses lead to so-called term document matrices. And here is one example of such a term document matrix. It's from, I think, a medical study. And we see in the first column the n-grams. In that case, unigrams. So that means only one word, not combination of 2 or 3 words, only one word for that reason, unigrams. And then we see here the frequency. And in that example, the word method is very frequent, comprise is very frequent, acid, cell, antibody, sequence, and so on. And you see the frequency is decreasing. We have sorted it according to the frequency here. And we can easily see what is in these texts. What do they talk about? So they do not talk about nanotechnology. They do not talk about sophisticated electronics. They talk about biology, chemistry, and they talk about diseases. Here in this case, it's, for instance, cancer, and we have marked it, highlighted it in yellow color. Now we have here the first column with the terms of a document set, the second column with the frequency, and now the term document matrix says, okay, how is this frequency distributed about the documents in the document set? And now in the first row, you see some numbers, and these numbers are representations for US patents. So these are indicators for the document, and we could write the title, for instance, in contrast to the number, but they indicate this is US patent 6,373,065 and so on. And now we see in this first document, the word method is only twice, and the word antibody is 10 times, and the word select and consist is twice again, and so on. So we can see here column per column the distribution of terms per document. And that's quite cool because we can do a lot of analysis with that. For instance, we can make a cluster analysis out of that to find similar documents, and similar documents having a similar distribution of those terms in the text body. And we can use this, for instance, also to calculate specific indicators for the words which are listed here as unigrams and so on. So this is a term document matrix, and in one of our exercises, we will use such a term document matrix, and we will use Excel to reorganize it. And one example to reorganize is here in the lower part here of this slide. And you see here the word cancer is in a row, and here the word cancer is in a column. And in Excel, you can just copy the whole sheet and then open a new table and then insert it in a transposed version. And then you get the columns to the rows and the rows to the columns. And exactly that is done here. And then we have sorted the whole sheet according to this column. And then we find very quickly all the documents in that document set which are dealing with cancer in the list of decreasing importance. So this is text mining, and this is leading to such a term document matrix. And it's quite a powerful tool which can be used very good to find a starting point for your analysis, to find a structure. And for instance, some colleagues here from the Institute in Bremen have analyzed the crane technology with that tool to find a way to start a road mapping exercise. And they developed different technical parts of a crane, not which are all in a crane, but which are discussed in the last time in the source of patents. That's a great difference. You do not take the crane as a technical thing, you take the crane as a thing which is influenced by inventions, and you search for those parts which are really important as inventions, and then you get your introduction to the road mapping exercise. So this is tech mining. When you have done tech mining, you can, for instance, as I said, use different things. You can visualize it, you can cluster it, you can extract important terms, and last but not least, you can do topic modeling. I don't know if you have heard of topic modeling. It's not really new, but its use is increasing in the last years tremendously. So perhaps just a short feedback, if you just raised your hand, who has heard about topic modeling yet? So I don't see a hand. Okay, so hopefully it's new. And I'd like to explain that. And if you do topic modeling, you normally do it with the programming language in R. The other things you can do with the text mining tools, which are also available in R or in Python. But the topic modeling is very nicely represented in R. And now let's have a look what topic modeling is about.
Professor Martin, I have a question.
Yes, please.
Do you have any recommendation of software free to do that? Because here in the ministry, we work with this kind of analysis, but we paid license, so expensive for 1 year, 2 years, and now we don't have money to do text mining in patent and scientific publication. Maybe if you know something software name, or I recommend you to work with this, because I know it's expensive to get that.
Yes, I think there are a lot of professional tools out in the world, but as you said, you have to buy a license. What we are doing in our institute, we are following two ways. The first way is we are using our advisor, which is open source. You can download it, but you have to translate the German abbreviations, but I think that's not too complicated. So this is really an open tool, and it offers the opportunities to extract different types of n-grams. It offers the opportunities to make measurements between documents if they are similar or not, and it offers the opportunity to get so-called multidimensional scaling out of that. So this is free. Or the other way which we are going is that we are using the R package. And perhaps you know the R package. It's also an open source project. And the important and interesting thing is that there are many, many libraries out in the world, and so are libraries for text mining. So you install the R package, and then you have to search for libraries which do text mining, but then you can use quite easily. It's not complicated to do programming in R. Quite easily the job and use this. And finally, a colleague of mine, he loves a tool which is called KNIME, and I will post it just for people. And I think it's not expensive and it's very visual, and that's nice with that tool. So you don't have to program explicitly, but you use a visual representation for the functions you want to have. And this is also an opportunity to do this type of text mining.
Thank you, Professor.
Yeah, you're welcome. Good. So having said this, let's have a look at topic modeling. What is topic modeling about? Here is an example from the inventor of topic modeling, which is Mr. David Blei. And he said, okay, let's have a look in a text. And we have in a text often a combination of different topics which are combined in this text. Here you see different colors. In yellow, for instance, the people are talking about something from biotechnology, DNA, gene, genetic. Then in pink is another topic, which is mixed with the first topic. And this is about life, evolve, organism. So this is more biology. Then we have a third topic in green, and this is about neurology, brain, neuron, nerve. And finally, we have in blue a fourth topic, data, number, computer. And so he says, okay, a text is often a combination of latent topics, which are combined in this text and which we should extract in order to find this interesting combination of things. And topic modeling is based on the term document matrix, which I just have introduced to you. And it is applied normally in R or Python, and then it extracts two different types of information. The first is here the topic, the document to topic matrix. That means you have your documents here, and you have your topics there. And then in the fields, you have the probability of a document relating to a topic. So coming back to the example, we have here the topic of biology, and let's say this is topic number 2, and we go into this line and we see, oh, document F is related with at least, okay, 1%, that's not much, to that topic. But here, for instance, topic number 14 and document number 7, it belongs with 45% to this topic. So we can see very easily which topics are discussed and which documents belong to these topics. This is kind of a cluster analysis, but it's a little bit more sophisticated. Second, what you can do is you get out of the algorithm a so-called term to topic matrix. And now we have here the topics in the columns. And we can see which terms belong to the topics. And these terms are listed in decreasing probability of being part of that topic. So we have different words on the first position, and we see that they are representing different topics. I'll give you an example for that. Here we made an analysis in the field of RFID technology. These are the small chips which can be used to identify objects or products or other things. And we made an analysis of patterns in that field. And now let's have a look. Topic 4, for instance, is the first word is authentication, token, secure, security, encrypt. And so we could say, okay, this topic is obviously about security and authentication. And so is topic 27, code, identification, database, system, unique. So these topics belong to that area. The clustering, and that's the unfortunate thing, the clustering has to be done manually. There's no algorithm at the moment which says these topics are belonging to each other. There is a multidimensional scaling available, but it's not perfect. So you still have to cluster it, but you get the topics. And for instance, if you look at topic number 6, card, credit, plurality, prepaid, computer. And I would have crossed out here what the headline is about. It would be easily to say it's about finance and payment. So we have here several topics dealing with that payment, point, sale, bill, platform. Easily to see this is about payment. And topic modeling for that reason can be also used to analyze such texts, huge amounts of text. That's the real advantage. Huge amounts of text, and to get the topics out which are discussed in these documents and to structure these documents according to their topics. Good. And in our exercise, I think we have also an application of topic modeling, but don't be afraid. You don't have to program the system. We have already done that, and we have a list of results, and you can work with this list of results. You can work with this list of results to do the exercise. Now I find something in the chat, and yes, I accept what there is in the chat. It's from Santiago Vaigosa, and he says that there is a free complement. It's called RStudio. Yes, and that's a development part for R, and we use, as you do, RStudio, and in this development space is integrated the programming language R, and then you can easily develop and test your programs and check what they do to your texts. Yeah, thank you very much for that thing. And okay, so our first tool was text mining. Our second building block was topic modeling. Let's go on to the next, and this is sentiment analysis. And sentiment analysis means that we not only want to know how similar texts are, but we focus on specific meanings of words and extract those meanings in order to get an understanding what the intention of the authors of these texts really is. This is called sentiment analysis, and two examples from early sentiment analysis. This was a good Google product search. It's not the recent Google product search, but they defined what people are saying. And they developed a tool to analyze the texts. What are the characteristics of that product? For instance, ease of use, value, setup, service, size, mode, colors. And here you can see how many people voted positively and how many voted negatively in this spectrum of different stars. So for instance, customer service is only 1 star. It's a large portion which is red, and 4 stars, no 5 stars. So the sentiment is, I do like honest tech support people, but obviously they are quite expensive and perhaps unpolite. So you get the information not only in a quantitative way, but you also get some qualitative information about what people think about this product. And this is done by analyzing words with meanings. And normally you have a library, or you develop a library for those characteristics on the left side and the meanings on the right side. And you develop this type of sentiment analysis. Another example is by the competitor of Google. It's by Bing, and it's similar in that case. You see also here what is mentioned for a product, in that case for a printer, what is mentioned as characteristic, and they extracted it and they said, okay, how often is it mentioned? And you can also get sentiments to get the feeling of the people about those components, to see what they really think about this product. Good, and another example for sentiment analysis is a Twitter sentiment analysis, and we see here Twitter sentiment about the trade market, the stock market. And the blue line is the Twitter sentiment. This is the analysis what people said in their Twitter tweets. And the black line is what the Gallup poll says as the opinion of the market. And you see it's very, very near to each other. So sentiment analysis can replace traditional polls and can replace a lot of expensive tools. And especially if you are in a situation in which you do not have a lot of money, then perhaps it's interesting to use these data, big data driven things to get the information out of it. So now that we have seen some examples, I skipped that one, of sentiment analysis, I'd like to show you how this is done. And this is from the Stanford University, and they trained their sentiment analysis with movie recommendations. So they had a platform on which they had a lot of movies, and they analyzed the sentences which have been written by the viewers of these movies to train their sentiment analysis. And here are some examples of those things. For instance, the touching and heartwarming film is the most perfect celebration of the human spirit I have seen. And now, for you, as a human being, it's easy to find the sentiment. It's positive. Yeah, the touching and heartwarming film is the most perfect celebration. It's really positive. Now we have to train a computer to think that this sentence is positive. And I'd like to get a different example, the last one, because I think it's so nice. This is definitely positive. And here, saying this is the #1 movie of all time is like saying McDonald's makes the best hamburgers. Now, it's not easy to find the sentiment for a computer. For a human being, it's still quite easy because we know that McDonald's makes good hamburgers, but not necessarily the best hamburgers in the world. And that perhaps in a restaurant in Argentina or in Brazil, there are better hamburgers than from McDonald's. So we know this is a little bit ironical. And that means that the sentiment is negative. And now it's part of this tool, and as I said, it's from Stanford University, to analyze such a sentence. And here are two of the examples. And we can see one of the finest films made in recent years and so on. We can see they split up the sentence, not only in n-grams as we have seen it before, but in components, and they try to summarize those components and especially the sentiments. And here we have the finest films. This is positive. Off is without influence, and one is still positive. And here we have different words also combined without sentiments. Finest is the only adjective, and this is going up to the root of the tree, and here the tree says this is positive. And I just see in the chat that just a moment. Tainara has studied this in syntax and linguistics, I think. And thank you for that chat. And if I'm telling you something which is wrong, please correct me, because this is not our development, it's from another university. But I think one can see the mechanism, yeah? Identify the adjectives and identify if they are negated or if they are supported positively. And we can see, and this one is the example I already gave to you with the ironical tone. And now we find the adjective best. Best is positive. And now let's look at the surrounding. The best hamburger is still positive, makes still positive, and so on, and so on, and so on, and so on. Now we go up the tree, and then we find here a negative symbol, because this is introduced from the saying this classification, which comes down, and we see, okay, although there is a part of the sentence which is positive, in the end, the sentiment is negative. And this is quite impressive, because normally, if you do sentiment analysis, if you do a simple form of sentiment analysis, you just have lists of words and you count how often they occur. For instance, the word nice, or the word famous, or the word illustrative. And you have a list of positive connotated words, and you have a list of negative connotated words, and you just count the words, and from the word count you come to the sentiment. But that may lead especially to mistakes if you have, as in this case, ironical aspects. And so this is quite an interesting tool to use. And Mireille Tainara just writes, yes, my master's in linguistics, great, everything is all right so far. Thank you very much for it. Okay, now the problem with that is that this system is trained with movie data, and that we are talking not normally about movies when we talk about biotechnology, when we talk about gene technology or so. So it is working quite interesting, good, but not always good. But there are still new developments going on, new training systems going on for that type of thing. Good. What can we do with sentiment analysis? We can get the emotions related to a topic. We can get the sentiment towards a target. When we are, for instance, suggesting scenarios for a city, we can get the sentiments of the participating people. We can determine the attitude of people who write something. And as a short example, we once analyzed the yearly reports of large companies, and especially the letters from the CEO. And it was quite interesting. When the year was good, the CEO wrote, I did that, and I decided to buy that, and I agreed with my colleagues to make the merger, and so on. And when the year was bad, the CEO said, oh, hard competition, negative influence from the markets. So not he or she was responsible, but everything outside was responsible. So we could predict quite easily from the letter of the CEO how the year for the company was. And that is the determination of a writer's attitude, also supported by sentiment analysis. Good. Now we have seen three types of analysis from big data. And finally, I'd like to move to one building block, which is done with experts, qualitative expert interviews. And I discussed it with Lena Kronemeyer if we should talk about that. But at least in Europe, it's quite interesting that many people nowadays, especially from social science, they make interviews in a slightly different way than in former times, and they especially they get information out of interviews in a slightly different way. And for that reason, we selected qualitative expert interviews as the last building block for our future studies. And what is an expert interview? There is a typology of different interviews on this slide. And we have here the different interviews: in-depth interviews, oral history interviews, focus group interviews. And normally you have this first type, the in-depth interview with 1 to 2 participants, and you have long time and open-ended questions. This is often used to get the real opinion of an expert and not to lead him or her to a specific number or to a specific answer. And this is also used in many studies, in many future studies nowadays. And I think the positive thing is that the researchers, they moved from standardized interviews to open-ended questions, and to get more of the information which is not so obvious than other information. And when we are doing these interviews, we normally have 3 criteria for the quality. First is that we have the intersubjective comprehensibility. So it's not depending on the interviewer what is answered. We have second approach, which helps us to come from a theory or to come from a topic to the questions. And the third thing is we have researchers who are neutral and open to also accept when people say something which is not in line with our traditional thinking and in line with our traditional findings. And why is it important? Why is it good? Because sometimes things are not so easy, and people as experts, they have a perception which can be different from our perception and which can explain things which we haven't seen before. And for that reason, this approach is quite nicely and usable. And it's based more or less on the grounded theory approach from Corbin and Strauss. And they said, okay, in some cases, especially when the times are changing quickly, we need to prove our existing theories by really asking people in the field openly. And this is the idea behind that. Now, I just want to focus on 2 things. There is a procedure in different steps to develop such interview guidelines and to collect information out of the interview. And the first is the development of those interview guidelines. And here we can see an example that in a good interview, we start with a research question. For instance, in that type of example, we ask what institutional conditions can explain specific achievements in the commercialization of biotechnology in the 3 states. I don't know which 3 states, but you can imagine that perhaps it's Brazil, Argentina, Chile. So we have 1 research question. And from this research question, we move on to so-called analytical dimensions. And I think there's a nice similarity to topic modeling, because these analytical dimensions, they are in the specific thinking the topics in that question. So for instance, what do they talk about? They talk about the financial system, they talk about regulatory system, they talk about education and science, and they talk about national innovation policy. That are the analytical dimensions. And if we would have used topic modeling for a larger portion of text, perhaps we would have come up with these dimensions as well. And from these analytical dimensions, the interview questions can be derived. So we can ask, what do we want to know about the regulatory system from our interviewees? What do we want to know from the education and science side from them, and so on? And we can transform that to question sets for each dimension. And then we have our questionnaire developed in a systematic and scientific way. This was the first thing, which I think is a little bit different today compared with 10 or 20 years ago. The second thing is that we use normally tools to get information out of the interviews. And there's a software, different softwares in the world. One is MaxQDA. And this software helps in getting information out of the interview. And for that purpose, one has to transcript the interview into text. That means we don't have only the audio recording, we have also transformed the audio recording to text. And this text then can be used to do the so-called basic coding in such a software system such as MaxQDA. And I have one example here, which is very small, but you do not need to read what there is written. But we have here the interview in the center, and we have here different topics at the left side, different codes. And so we assign this part of the interview, for instance, to this topic, and this part of the interview to this topic, and so on. And then we do not only one interview, but we get 20 interviews or 40 interviews, and then we can organize the interviews according to those topics. For instance, we can click then on that topic, and then we get all the parts of the different interviews in which an expert said something about this type of topic. This is quite interesting because these topics can be derived from pre-knowledge, from theory, but they can also be derived from the interviews. And this is what is interesting, because if you have something in the interviews and the experts say, oh, that's so important, but you do not have it in your list from theory, then you have found a new aspect, and you have found an aspect which has to be integrated into the theories, or which establishes perhaps a new theory or a new aspect. And this way of organizing interviews is quite helpful also in future studies, because it's very good for discussing, it's very good for getting acceptance of your studies. You can show what people said, for instance, to the economic environment in a specific country, or you can show what people said about technologies and so on. Good, that was a short run through 4 different building blocks. I'd like to summarize that with 3 simple sentences. First is, they can help us really preparing essential parts of future studies. They have different origins. We said big data, we said expert-driven, we said participation-driven. Big data nowadays plays a major role because we can access it so easily. And last not least, building blocks can be triangulated. That means that we can get the results from one building block and compare it with the results from another building block. And if they fit with each other, then we have a positive triangulation. And if they don't fit, perhaps we have a problem, or we have found something interesting, because probably we have to dig deeper to understand why this building block led to this result and the other building block led to another result. Good, that is my input at the moment, and I'd like to invite you for questions or remarks. Yes, please.
Thank you, Professor. Yeah, so it's been very interesting to get to know all these techniques. It's very insightful. I just have a comment, and I have the feeling that maybe one of the drawbacks of this text mining is that because of the setting of the techniques is quite subjective. For example, the classification of topics, or the categories when you're analyzing the qualitative interviews. It may be, there's always a space for bias, for personal bias, which may make it difficult to analyze new trends. So I was thinking, for example, when you are building the topics, let's say that there's a new technology is starting to emerge. And for example, I don't know what, there's a whale in my, sorry, in my camera. So for example, if there was a new technology that is emerging, for example, converging two different technologies, I was thinking, I don't know, maybe a new security development that is related to neurology. But if you separate those topics from the beginning, maybe you will be missing that the opportunity to see that new trend. So it was just a remark that yeah, there's maybe a drawback because of an initial bias you may have.
Yes, thank you very much for that remark. And yes, that can be a drawback, but sometimes you can also use especially this to find those new technologies. So for instance, if these two old technologies which converge form two different topics, and you find documents in which these topics are combined uniquely, then perhaps that can be an indication that here's something going on which is interesting. But you are right. It's also the examples which I have shown, they are partly subjective. We try to apply so-called reliability measures. So that means when we have made an assignment, we ask somebody else to do the same job, and then we compare if there are the same results. And we try to develop a list why we do something. So we have a coding scheme, and we improve that coding scheme by using different people to assign something. But it's still, and I have to accept that, it's still partly subjective. The advantage is accepting this limitation. The advantage is that you can use it for a huge amount of data, that you can use it for thousands of documents, which you don't have to read manually. And I think that's quite still a huge advantage. Thank you. Any other questions or remarks?
Yes, Professor, I would like to, from your experience in the market, because we have academia and we have the market and we have the enterprise, how widespread would be these big data methodologies actually in the market, not in the academia, but I think that from the academia, perhaps it's more it's the focus of academia, but I can't see in the enterprises these practices. But it's just a point of view. I would like to know about your experience in the market.
Thank you very much for that question. Perhaps it's a difference between Europe and Latin American. In European countries, it's very, very common. And there are many consultants doing that type of stuff. So two of my PhD students, of my former PhD students, they now work for a major automotive company. And they are doing exactly this type of stuff to analyze companies which can be bought, startups which can be bought, to analyze suppliers if they have a technological capacity, to make studies in technology roadmaps for a specific technology, how to get into it. So I think at least in European companies, it's quite common to use these tools. And sometimes this is like a wave. It starts in a specific part in the world, and I think it started in the US, to be honest, and then it waves to other countries, and it comes sooner or not so soon, but probably it will be part of our life.
Thank you.
Good, ladies and gentlemen. I think it's time for a break. If you have more questions, please feel free to ask them later on. On my watch, it's 11:30. So we make a coffee break. Let's make it to 10 to 12. So we have a quarter of an hour, 10 to 12. We will start with our hands-on session. So thank you so far, and see you in around 15 minutes. Similar to yesterday, first topic that was discussed in such a study, it was about cloud computing. And I think everybody knows cloud computing is one of the major things of today. We move from individual computers to pooled computer sources, and cloud computing is an important business also for companies such as Amazon or Google or for IBM and others. Now, Kaiser and others, they did an analysis of cloud computing, and they started not with a Google search, but they had a process model developed. And the first thing was to have a keyword analysis from a search in publications. So they said an important source for cloud computing can be found in publications. And we try to understand what different topics are discussed in those publications in order to find a way to make a road mapping exercise. So they did data extraction, they did a keyword analysis, and then from that step one, they moved on to different analysis, technology development, market development, and so on. And they combined those things in a cluster analysis of terms, in an association analysis, and in a network analysis. And finally, they checked the integrity and consistency of their approach. And we don't need to discuss the details of that, but I think it's nice to see that there is a method, road mapping, and this method is powered and supported by different building blocks, and these building blocks in that case come from publication analysis. And so far, it's a nice example that this can be a very valid approach. Let's have a look. Here we have some results from the publication analysis, and you see a word cloud, which is also a representation of a term document matrix. And you can see different bgrams. They use bgrams as well. what is discussed in relationship to cloud computing. For instance, service providers or virtual machines or data centers are discussed. And these things are extracted from the abstracts of the publications. And if you look at the keywords which the authors used, they talk about grid computing, they talk about virtualization, they talk about MapReduce or performance and other things. So you get an idea what is discussed in relationship to cloud computing. And for that purpose, Kaiser et al. Used 1,600 papers on cloud computing. From the Web of Science, they did the extraction of abstracts and author keywords. They made a text pre-processing. That means they deleted stop words. They tokenized those keywords and they extracted bgrams, as you have learned it already. And then we see here the word clouds as a result. And they found that cloud computing is a heterogeneous field. Then they moved on in step 2, started the road mapping process, and again used text mining for that. And they extracted the related terms from publications. And you can now see here on the right side a diagram in which the development of the usage of these terms is presented. So, for example, here we have a term, and this term is infrastructure as a service, and it started already in 2000, then it grew to 2005, but then decreased and then came back from 2008 on. So we get an idea in which time which things have been discussed. Or another term which is not there very early, we can look at these different terms here. This one is virtualization, for instance, and we see it all started not in 2000, it started in 2003, that people started to talk about virtualization and to develop the related things. So this helps us to analyze the status quo, as one of the participants said just ago, and it helps us to get an idea how to structure our road mapping exercise. Now they did some more analysis. For instance, they showed a portfolio of different terms. So we have emerging terms, we have established terms, declining terms, and core terms. And that helps us again to get an idea what the technology is about. And now we can use these results to combine them, for instance, in a cluster analysis. That means we can search for documents which are similar in the structure of their bgrams. And that's quite easily done in a cluster analysis. For instance, with R, you can do a cluster analysis, or with SPSS or any other statistical program. And then you can see if there are fine clusters and you have different streams of literature which you can deal with. And they love fancy diagrams, so they made also a co-occurrence network of keywords, and we can see the combinations of different keywords and their relationship with each other in that diagram here. And finally, they made a road mapping exercise and put in those findings in the road mapping exercise in order to structure it for cloud computing. And that's the first case study I'd like to share, I'd like to show, and the result is, I think, quite interesting. So it's also published, and one can see that it's quite interesting to see how different building blocks have been integrated in this road mapping exercise. First example. Second example is a scenario approach. And here we have wonderful links back to our Enrich course. Road mapping was day number 3, I guess, and scenario was day number 4, was yesterday. And the scenario approach took the quantified self into consideration. That means the self-monitoring and self-tracking applications. And I don't know, perhaps many of you do that as well. And I do it when I do sports. So I monitor my heart rate and these things. And this is quite an interesting technology. And again, Kaiser and her colleagues wanted to do a scenario approach about the quantified self. So as they are good in text mining, they tried to do it not similarly, but in a slightly different way. They wanted to find first literature and doing a consistency analysis. And they decided to use a new source, namely Twitter. And that was, in my opinion, quite cool, because they said, okay, when we want to learn something about the quantified self, okay, we can look at publications, but this is discussed in so many hashtags, so that we can go to Twitter and find at least people talking about the quantified self. So that was their way. They said, okay, let's look on Twitter which topics are related to the quantified self, then analyze the tweets and look for the hashtags, then extract the links of the homepages of those people who talked about that. And then they made web mining. That means they extracted, they crawled all the web pages of all the people who talked about the quantified self. So here we have, I think, a very impressive example of how big data can be used for such a study. And as I said, this is not a road mapping approach, this is a scenario approach. Then when they had the web pages, when they did the web mining, they made first a concept mapping and then a topic modeling. And now you know what topic modeling means. And so they used a lot of those building blocks that we have talked about today in order to support a method which we have talked about yesterday. And then we see here input for scenario development. So this is the foot for the scenarios. Now let's go a little bit into the steps. First step is from Twitter, and the key parameters have been set here, quantified self, and they only looked for tweets between May and September, and they found 25,000 tweets, to that 18,000 in English. And so they had a basis network of people talking about quantified self. And I just see in the chat that somebody is writing the trending topics on Twitter are always something to look close. Yes. So it's a wonderful starting point because people want to get retweeted, so they post interesting things normally. Now they made a hashtag network. That means they used the information out of the hashtags and tried to find the different topics that are related to that. For instance, wearables, mHealth, digital health as parts of this cluster here, or fitness as part of this cluster, and health again. or the data cluster, big data, data tracking, and so on. So they received an impression what people talked about when they talked about the quantified self. And you see that there are some things which are quite usual to talk about, but also others feedbacking, for instance, that are quite interesting, how you can do that and why you should do it. So now we have this hashtag network, and then the next step was to do a web mining, to look at websites from those guys who wrote about the quantified self on Twitter. So this is quite a huge amount of work, I think, but they used a Python package, beautiful Zoop, and this package was feeded with the links from the Twitter accounts, and then 1,300 websites could be used and retrieved. And so they crawled the website, they took all the text they could get from the websites of those people and used it as next input for the next step, namely concept mapping and topic modeling. And here we go on. This is a concept map, and we see terms and their relationship with each other. And this was extracted here as part of 8 different themes. So we have 1, 2, 3, 4, 5, 6, 7, 8. Hopefully it's the same. And they said, okay, we can cluster it around data, people, users, experience, social, rate, Apple Watch, and work. And the center of all of that is the topic of data, health, not data. Health is the center of the data. Yeah. And now we can already do something with that. We can say, okay, obviously it's not only about the self, the quantified self, it's also something about social things. So it's important to understand that if we make scenarios for that topic, we do not focus on the individuum as one person, but we have to focus on the person in a group of other persons, because obviously the social aspect is discussed on these web pages, and it seems to be an important aspect. So this is one of the first findings we get from such an analysis. And then Mrs. Kaiser did topic modeling, and you learned what topic modeling is about. And she had problems doing that as well, because it was not easy to interpret the topics. And here are 5 of the topics, and you can see here's the potential, and the topic words are listed in a decreasing order of probability. So we have here potential, search, condition, health, record, secret, theme, charge, decision, code, exist. And I hear now one of the participants saying, oh, this is subjective. Yeah, and they found one word, one term, which looks good, potential. And so they said, this is the potential topic. And so if we go to the next one, it's a little bit better, I guess, because we have here Apple Watch, Fitbit, watch, fitness tracker, and so on. So it is about wearables, the hardware and the devices. So I think this topic is acceptable from the interpretation. Then we have meetup, toolmaker, talk, event, funding, show, program, conference, group, check. Okay, this is about user exchange. I think this is a good topic as well, and so on and so on. And so they analyzed the web pages by means of topic modeling, and they made some thresholds. For instance, terms must occur at least 30 times to be considered in the analysis. That was what we did in our task number C in the last part, or that the authors here used data, health, and wearable topics to be considered in the scenarios. So now we have topic modeling, and then the next step is the scenario development, the key uncertainties, as we have discussed it yesterday in the morphological table. We have different key factors, we have different values of those key factors, and here these values have been analyzed by means of the topics already found in the web pages, and then they developed 3 different scenarios for the quantified self. So for instance, scenario 1 is called sensor mania, and that means that quantified self is integrated in everything. And so for instance, is integrated in our daily life. Everything is connected. Sensors are mass produced, and healthcare applications are far developed, even used in epigenetic applications. That goes really, really far. Scenario 2 says connected aging and health-centric applications. So not for everybody, but for people who really need it. Old people, people who have a disease. So this is a different scenario for quantified self. So quantified self is especially used for serious applications. So for instance, in the healthcare field, less for sports and fitness. And generally, the hype is over. And this is scenario number 2. And scenario number 3 says quantified self has been established. What next? And it's again a different scenario for this topic. And here we can see that with different scenarios, we can see perhaps different possible worlds. And sometimes those different possible worlds, they mix. So perhaps the truth is not scenario 1 or 2 or B, but part of the world will be focused on scenario 1, another part on scenario 2, and a third part perhaps on scenario number 3. And that is, I think, again, a very nice combination of building blocks and methods. The scenario method is used, but building blocks are found by text analysis, by topic modeling, and so there is an input from these building blocks directly into the method. Good. Let me sum up those experiences again with the same 3 sentences which I mentioned before. First, building blocks can help preparing essential parts of future studies. And often building blocks are not expensive, and that's good news for all people doing such studies. Second, building blocks have different origins. Yes, but big data nowadays plays an important role. And it's good that we have such a huge amount of data which we can use for it. And third, last not least, building blocks may be triangulated. So if you have done this Twitter analysis, you have done the website analysis, you could do a publication analysis in order to see if the results are similar or not. And if the results are similar, then it's fine. But if they are not similar, then it's interesting. And you can say, okay, what are the reasons for those different results? And can I perhaps integrate those reasons? Do I have to integrate those reasons into my future study, be it a scenario analysis or anything else? And I'd like to end this part of the presentation again with the figure from the beginning, where we had 3 different things. We had the methods, scenario method, Delphi method, road mapping method. We had the building blocks based on big data or on expert knowledge, and we have larger approaches in which different methods are combined with different building blocks in a way to bring something to get access to a topic which is of interest. Good. Any questions at the moment? I stop that and look at you. Any questions? No, then I proceed. So it's just the next step, the closing discussion. And we have here Lena Gronemeyer, we have Adriana Sanchez-Rico here. I don't know if Ralf Isenmann had the opportunity to join us. Normally he is also here. He made the day on road mapping. And I think it's perhaps a good opportunity to have a look back to the first day. And the first day gave us an overview about the methods of future research. And we had discussed different methods, not all methods, but many of them. And here we see them. For bold forward thinking is a good method, as Ray Kurzweil, for instance, did that. Then we have seen the Delphi method. We made an exercise, the enrich mini Delphi. We have seen yesterday the scenario method, which is a good method, a very common method. And we did a small exercise on that. Then what we not looked at were forecasting methods for time series. There you better go to statistical professionals. What we didn't have a look at is system dynamic modeling, which I personally like very much because it looks in dynamics, it looks in loops, and trend research is for getting the recent trends in the world. And finally, forecasting markets are there, for instance, to predict the results of a poll or this kind of stuff. So we have found a lot of hopefully interesting methods, and I hope that you find those methods interesting and you try to use them. It's good if we just remember what the basis of these methods are. The basis is that the future is uncertain, and each of those methods tries to deal with that uncertainty in kind of a different way. So for instance, if we look at those two things which we have discussed in detail, Delphi method and scenario method, in my perception, there are two major differences. The Delphi method, it says I have some hypotheses and I do not know when they will be valid. So I have to ask my experts when this hypothesis will be valid. And so I have such as a line of hypotheses, and then I can make a cut and can say what hypothesis will be valid until the year of 2030, which one will be valid until the year of 2040, and so on. And that's the way how the Delphi method looks into the future. And it is focused directly on the topic under research. And so this is one way of using a method, and the uncertainty is represented by the distribution. Yes, the distribution of the timing of a hypothesis. And this is the way of the Delphi method to deal with uncertainty. It's differently in scenario methods, because in scenarios you have different worlds, different scenarios of the future. And the uncertainty is represented in the differences, in the spread of the projections in the spread of the different ideas about the future. And the scenario method, in contrast to the Delphi method, is a method that looks really in an ecological perspective. It says, let's have a look at the conditions and the environments of a topic, and we interpret the development of that topic not as a development driven by itself, but as a reaction and adaptation to the environment. So for instance, if we have more climate change, then perhaps some computer systems will change accordingly. They will not change because they are computer systems, but they will change because they have to adapt to different climate conditions. And that's the basic idea behind the scenario technique, and the representation of the uncertainty is by the different scenarios which we place in a time in the future. And so we could go through other methods as well. System dynamic, for instance, is making simulations. And if you change some parameters, you get different results. And doing so, you get different distributions of your results. And it's a little bit similar to the Delphi method. So you get here a third way to represent uncertainty of the future, and at the same time make predictions what the future can be. So this, I think, is a short summary of that what we learned and discussed. And again, we have here this table in which we tried to give advantages and disadvantages, or strengths and weaknesses of those methods. And interesting in my perception is also the question, can we combine these methods? And the answer is yes, we can. For instance, when we are doing a scenario study, often we use Delphi results from a Delphi report that has been done for the Ministry of Research and Technology in Germany. So we pick out of the Delphi report specific hypotheses. We look when will they be in place, and then we stimulate the discussion around the descriptors and projections in a scenario approach with these Delphi hypotheses, which we get from a Delphi report, which is public in Germany. So we can combine these methods. We can use building blocks, as we have seen, and we can put them into larger approaches. We can make a Foresight approach for a ministry, for instance, and integrate different methods, different building blocks into them. Now, that was my short summary. And now, before I pass the word to Bruno, it's time for you. If you want to give us some feedback, if you have some more questions, if you have comments, please feel free to show your hand and to give us these questions or comments, and give us a little bit of feedback for that lecture.
It is quite a lot of learning, so we have yet to process, but really enlightening, especially to see the integration of the different methodologies, how they work in different ways and for different reasons, but also, as now in your final summary, how we can use them integrated, if that's the point, right? The better solution for the object, the analysis that we are trying to make.
Yes, thank you very much. for that. Any other comments? No.
Martin with us is my boss, the National Director of Study, Vanessa Lowenstein, is the person who allowed I'm here. So she wants to say something for us because now in the Foresight program, we're working with this methodology, techniques, knowledge, and trying to do best works. And we don't have a lot of resources, you know. And so for that, Vanessa and me, I'm so helped. So thank you to this Foresight course, and I want to present us.
Yeah, thank you very much.
Yes, Martin and Enric and everybody, I really would like to thank for having the opportunity. Well, my name is Vanessa Lowenstein, as Adriana said. I'm the National Director of Studies here in the Ministry of Science, Technology and Innovation from Argentina. I really would like to thank all of you for having the opportunity of being part of this activity, especially to Adriana, who has been there with you working a lot. For us, it's a pleasure, and we are open to be part of this sort of meetings, activities that take place here in Argentina or in the in the web, by the web, by Zoom, and all these new methods. For us, it's really important to combine. I don't know, we here in the direction, we work on intellectual property rights, technology transfer, and we link those issues with all what we are doing here. So it's an exchange, and we try to build synergies in order to work better and to promote technology transfer, to think future scenarios and all these topics. And well, I only want to thank Enric and all of you participants, professors, and Martin, you particularly. And well, we are here to keep on working together. Thank you very much.
Thank you. That was very nice that you took the time to come to us and to give us these nice words. From my side, I'd like to say thank you. It's a great experience, and I may speak for Lena Grunemeyer as well, to work with you from Latin America. It's a nice culture. We see so many friendly people there, and you are working so good together. I'm really, really impressed. And so for us, it was an interesting time. Also hearing Adriana, it was an interesting time, and thank you very much for your participation. And now I'd like to pass the word over to Katrin Singer from Enrich and Luck, and she has the closing words.
Thank you very much, Professor Mörle. Yes, thank you. Thank you so much for participating in this course today on behalf of the entire Enrich and Luck project. I think it was a very, very interesting course, and we learned a lot. And this is actually what Enrich and Luck stands for, to working with within different countries on innovation-related topics. So my thanks, special thanks goes to the experts who provided us with this in-depth knowledge on foresight and technology planning. Thank you very much. Yes, I would also like to invite you to participate a small survey on this course, because it would help us also to identify relevant topics for future activities, and also to improve currently ourselves, which I would yes, post into the chat. And also a link to our newsletter, which you could subscribe in order to stay tuned on the Enrich and Luck activities and to keep in touch. So thank you very much to all of you, and I'm looking forward for fruitful further discussions. And I would give the word to Bruno also.
Thank you, Catherine. You were perfect and complete. I would like just to reinforce and thank you all, Vanessa, Adriana, Professor Mörle, Ms. Grunemeyer, and mainly all of you participants. This is, as Catherine said, this is what we are about, and it's really a pleasure to see such a level of content, of experts being able to join us, and also you participants, members, and partners. It's great to see that this is one of the best examples that we could have of the mission that Enriching LAC stands for. So again, thank you very much. Hope to see you soon in our next events and courses, and keep in touch. I'm at disposal for any questions, suggestions, and for ideas for a next encounter for all of us, okay? So have a great week, and again, thank you very much.
Thank you. Bye-bye.
Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye.
Bye-bye.
Thank you.
Bye. See ya.
Thank you very much.
Okay.